In early 2026, a team of independent researchers fed every available structural scan, geological survey, ground-penetrating radar result, and peer-reviewed engineering study of Baalbek, Lebanon into Grok AI, the large language model developed by Elon Musk's XAI. They asked a simple question: analyze the site as an engineering project. Ignore the archaeology for a moment. Ignore the mythology. Ignore the tourism brochures and the ancient alien documentaries. Just look at the structural data, the geological context, the material properties, and the construction sequence, and tell us what this site actually is. The answer Grok AI returned was not what anyone expected, and what it changes is how we need to think about Baalbek and possibly about every other megalithic site on Earth. Because according to the analysis, the massive stone platform at Baalbek is not a temple foundation. It is not a monument to the gods. It is not an expression of imperial vanity or religious devotion. It is a seismic damping system, a structure engineered from the ground up to survive earthquakes. Using principles of base isolation that modern engineering did not formally describe until the 1970s. Optimized specifically for the geological characteristics of the Dead Sea Transform Fault, the exact fault system that runs directly beneath the Bekaa Valley where Baalbek sits. And that was only the beginning of what the AI found. But before we get to the rest of the analysis and the part that genuinely disturbed the researchers who ran it, we need to understand what Baalbek actually is, because most people have heard the name, most people have seen the photographs, but almost no one understands the scale of what is sitting in that valley. Baalbek is located 67 kilometers northeast of Beirut in the Bekaa Valley of eastern Lebanon. The site is officially classified as a Roman temple complex. It has been a UNESCO World Heritage Site since 1984. The Romans built three major temples here: the Temple of Jupiter, the Temple of Bacchus, and the Temple of Venus. The Temple of Bacchus is one of the best preserved Roman temples in the world. The 6 remaining columns of the Temple of Jupiter stand 65 feet tall, among the largest columns from all of classical antiquity. All of this is documented. All of this is real. The Romans built here. Their decorative stonework, their column styles, their architectural grammar are unmistakably Roman. But the Romans built on top of something that was already there when they arrived, something that is categorically different from everything the Romans constructed above it: the platform. The foundation upon which the Temple of Jupiter stands is called the Grand Terrace, and the Grand Terrace is where every conventional explanation falls apart. The outer wall of this platform is constructed from enormous, finely dressed limestone blocks. The lower courses feature stones ranging from 30 to 33 feet long, 14 feet high, and 10 feet deep. Each one weighs approximately 450 tons. 9 of them line the north side, 9 line the south side, 6 line the west side. And resting on top of those 6 western blocks, elevated roughly 20 feet above ground level, are the 3 most famous stones at Baalbek: the trilithon, 3 horizontal monoliths, each one 62 feet long, 14 feet tall, and 12 feet thick. Each one weighs approximately 800 tons, 1,600,000 pounds per stone. To put that in perspective, the heaviest stones in the Great Pyramid of Giza weigh around 80 tons. The trilithon stones are 10 times heavier. The stones at Stonehenge average 25 tons. The trilithon stones are 32 times heavier. The largest stone the Romans ever demonstrably moved in Rome itself, a capital block for Trajan's column, weighed 53 tons. The trilithon stones are 15 times heavier than anything Rome built in its own capital. And in 2014, a team from the German Archaeological Institute, working in the ancient quarry 900 meters from the temple complex, found a 4th stone. It was still partially buried in the bedrock, 64 feet long, 19 feet wide, and 18 feet tall, with an estimated weight of 1,650 tons. That is heavier than 4 fully loaded Boeing 747 aircraft. It is the largest known carved stone from antiquity, and it was found beneath another massive stone, the Stone of the Pregnant Woman, itself weighing over 1,000 tons, which means that to extract it, the builders would first have had to remove the stone sitting directly on top of it. Neither stone was ever moved to the site. They sit in the quarry to this day, abandoned. Whatever civilization was carving them stopped in the middle of the work and never came back. Now, with all of that in your mind, here is what Grok AI found when it looked at the data. The first finding was the seismic analysis. Baalbek sits directly adjacent to the Dead Sea Transform fault system, one of the most seismically active geological structures on Earth. This is a transform plate boundary, similar to California's San Andreas Fault, where the Arabian tectonic plate slides past the African plate along a fracture zone that stretches over 1,000 kilometers, from the Red Sea through the Jordan Rift Valley, all the way to southern Turkey. The Yamune Fault, one of the primary strands of this system, runs through the Bekaa Valley. Its estimated slip rate is 4 to 5.5 millimeters per year. It produces major earthquakes on a cycle of roughly 1,000 years. The region has been devastated by catastrophic seismic events repeatedly throughout recorded history. In 1202, an earthquake estimated at magnitude 7.4 struck the region, one of the strongest in the Levant's recorded history. In 1759, a sequence of 2 major earthquakes occurred. The first was estimated at magnitude 6.6 in October. The second was estimated at magnitude 7.4 in November. They destroyed every village in the Bekaa Valley. The ramparts and houses within Baalbek were completely leveled. Drawings made before and after the 1759 earthquake show that 9 columns of the Temple of Jupiter were standing in 1751. By 1767, only 6 remained. Ground ruptures several yards wide formed along the valley from Baalbek northward for a total distance of roughly 100 kilometers. Before these recorded events, the region endured centuries of additional seismic destruction. Earthquakes in 115 AD, 363, 749, and 1033 are all well documented. The columns fell, the temples crumbled. The ornate Roman stonework, the arches, the capitals, the carved entablatures suffered catastrophic damage through 2,000 years of repeated seismic violence. But the megalithic foundation survived. The trilithon is still there. The 450-ton support blocks beneath it are still in position. The grand terrace itself, the massive platform that underlies everything, has not moved. The stones are still fitted together, still bearing the weight of everything above them, still showing the same sub-millimeter precision they were placed with originally. That is what Grok AI focused on. From a pure engineering standpoint, it should not have survived. The AI cross referenced the seismic history of the Dead Sea Transform with the structural properties of the Baalbek platform, the mass of the individual stones, the friction characteristics of the limestone on limestone joints, the multi-layered construction sequence, and the geometry of the foundation as a whole. It concluded that the platform's survival is not luck, it is design. The principle at work is called seismic base isolation. In modern engineering, this is achieved with rubber bearings, friction pendulums, and sliding systems that decouple a building from the ground beneath it, allowing the earth to move while the structure above remains relatively stable. The concept was first formally proposed in 1868. The first practical rubber bearing systems were developed in the 1970s by engineers in New Zealand. Today, base isolation protects buildings and bridges in earthquake zones around the world. What the AI found at Baalbek is a structure that achieves functionally the same result, through mass. The enormous weight of the trilithon stones, 800 tons each, gives them extraordinary inertia. In physics, inertia is the resistance of an object to changes in its state of motion. The more massive an object is, the more force is required to move it. When an earthquake sends lateral shear forces through the ground, a lightweight structure gets thrown around. An 800-ton stone does not. The seismic energy is insufficient to overcome its inertia. The stone stays where it is. But mass alone is not enough. If the joints between the stones were rigid and imprecise, seismic forces would concentrate at stress points, and the structure would eventually crack and fail. What makes the Baalbek foundation work is the combination of extreme mass with extreme precision. The stones are fitted so tightly that forces are distributed evenly across the entire surface of each joint. There are no weak points for stress to concentrate on. There are no gaps for water to enter and freeze. The structure behaves not like a wall made of blocks, but like a single continuous mass of stone. The AI conclusion was direct. The Baalbek platform is not over-engineered for aesthetic reasons. It is not megalithic because the builders wanted to impress visitors. The stone size is a structural choice, selected because it creates a foundation that is inherently resistant to the specific seismic forces generated by the Dead Sea Transform Fault. The platform is, in functional terms, an ancient seismic damping system. And then the analysis went further. The second finding was the network. When the researchers asked Grok to map every known megalithic site in the eastern Mediterranean and the Levant against the geological fault systems of the region, a pattern emerged. The Dead Sea Transform Fault system runs from the Gulf of Aqaba in the south through the Jordan Valley, the Sea of Galilee, the Bekaa Valley, and northward into Turkey. Along this fault system and its branches sit an extraordinary concentration of ancient megalithic sites. The Jordan Rift Valley has one of the highest concentrations of ancient dolmen structures in the world, massive stone burial chambers, some dating back thousands of years before Rome, clustered along and near the fault system. At Atlit Yam, off the coast of Israel, a semicircular arrangement of megaliths dating to the 7th millennium BCE was found submerged beneath the sea. Göbekli Tepe, the 12,000-year-old site in southeastern Turkey that rewrote the timeline of human civilization, sits in a region geologically connected to the northern terminus of the broader tectonic system. The East Anatolian Fault Zone, which produced the catastrophic Turkish earthquakes of 2023, is part of the same plate boundary network. The AI identified geometric relationships between these sites that align with the underlying fault geometry of the region. Not mystical ley lines, not sacred geometry in the esoteric sense, structural geometry, the kind an engineer would use to position monitoring stations or reinforcement points along a known zone of seismic vulnerability. Now, intellectual honesty requires a pause here. Correlation is not causation. Fault zones create valleys, and valleys have water, and water attracts settlement. Some of the correlation between ancient sites and fault lines is simply a correlation between fault lines and habitable geography. But Baalbek specifically contradicts that explanation, because you do not need 800-ton stones to live in a valley. You do not need sub-millimeter precision to build a home near a river. The engineering at Baalbek goes far beyond what habitation requires and enters the territory of what seismic resilience demands. And the same pattern appears across site after site, across thousands of kilometers. Massive stone construction in seismically active zones, built by cultures that supposedly had no contact with each other. The AI flagged this as the most improbable element of the data set. Not the size of the stones, not the precision of the joints. The pattern, the repeated independent emergence of the same engineering solution, massive, precisely fitted stone, at sites located along the same types of geological structures across a region that spans the entire eastern Mediterranean, was the striking result. The third finding was the one that disturbed the researchers the most. When the AI analyzed the construction sequence at Baalbek, comparing the oldest megalithic layers at the base with the progressively newer layers above them, it found something unexpected. The precision declined, not by a small amount. The AI estimated a decline in engineering precision of approximately 600% from the oldest construction phase to the most recent pre-Roman phase. The earliest stones, the ones at the very bottom of the platform, the ones that have been there the longest, show the tightest tolerances, the most sophisticated cutting, and the most precise fitting. Each subsequent layer is slightly less precise, slightly less refined, as if the knowledge required to produce the original work was being passed down through generations, but degrading with each transfer. Like a photocopy of a photocopy, each generation could still build. But each generation understood a little less about why the original builders made the choices they made. By the time the Romans arrived, the foundation was already ancient. The Romans recognized it as an extraordinary platform, massive, stable, sacred by sheer presence, and they built their temples on top of it. Their work is beautiful, their columns are magnificent, but their engineering, compared to the foundation beneath them, is crude. This pattern, declining precision over time, is the signature of inherited knowledge. Not discovered knowledge, not independently invented knowledge. Knowledge that was received from a source that understood it deeply, and then passed forward by successors who understood it less and less with each generation. Think about what that implies. Somewhere in the deep past, deeper than the Roman period, deeper than the Phoenician period, deeper than the Bronze Age settlements excavated beneath the Temple of Jupiter, someone built the first phase of the Baalbek platform with a level of engineering precision that has never been matched at the site since. And then that knowledge began to fade, not all at once, gradually, over centuries, perhaps over millennia, each generation building a little less precisely than the one before, until the knowledge was gone entirely, and all that remained was the stone itself, still standing, still holding, still surviving every earthquake the Dead Sea transform could throw at it. 900 meters from the temple complex, in a limestone quarry slightly uphill from the site, 3 enormous stones tell the final chapter of this story. The stone of the pregnant woman, 1,000 tons, carved but never moved. The stone of the south, 1,242 tons, carved but never moved. The forgotten stone, 1,650 tons, the largest carved stone from antiquity, found beneath the others, carved but never moved. These are not rough boulders. They are precisely shaped rectangular blocks with clean faces and defined edges, clearly intended to match the dimensions of the stones already in place at the platform. They were being prepared for transport. The work was underway, and then it stopped. Something interrupted the construction. Something caused the builders to abandon stones that represented years of labor. Graham Hancock, who visited the site, raised a question that conventional archaeology has never adequately answered. If the Romans quarried these stones and simply decided they were too large, why did they not cut them into smaller blocks and use them elsewhere? Limestone can be subdivided. The Romans did it routinely. The fact that these enormous blocks were left intact, uncut, untouched, unused, suggests that the builders who carved them were not the same civilization that built the temples above. And if the AI analysis is correct, if the platform is a seismic damping system, and if the precision declined over time, then the stones in the quarry may represent the last generation that still understood the original engineering well enough to attempt it. A generation that could still quarry the stones, still shape them to specification, but could no longer muster the organizational capacity or the technical infrastructure to transport and place them. The knowledge was fading. The stones were the last attempt, and then it was gone. Here is what we know for certain. We know that Baalbek has been inhabited for at least 11,000 years. Archaeological excavations confirm human presence going back to the pre-pottery Neolithic period. We know the Romans built temples at Baalbek beginning around the 1st century BCE. We know the megalithic foundation displays construction methods that are categorically different from the Roman work above it. Different cutting, different jointing, different weathering, different engineering philosophy. We know the Romans left no records of building the foundation. We know the region sits on one of the most active fault systems on Earth. and that the megalithic foundation has survived thousands of years of catastrophic earthquakes that destroyed the Roman structures above it. We know that 3 enormous stones in the quarry were abandoned mid-production. And now, thanks to the artificial intelligence analysis, we have a framework for understanding why, not how the stones were moved. That question has been asked 1,000 times, but why stones of that size were necessary in the first place? Because the answer, according to the data, is that the builders of Baalbek were not building a monument. They were building something designed to last, something designed to survive the specific seismic forces of the specific geological fault they were building on. Something that required extreme mass and extreme precision, not for beauty, not for intimidation, but for structural integrity across millennia. And they succeeded. The ground at Baalbek has been shaking for 11,000 years. Empires have risen and fallen above that platform. Romans, Byzantines, Arabs, Crusaders, Mongols, Ottomans. Earthquakes have flattened everything built on top of it, over and over again. Columns have toppled, walls have crumbled, entire civilizations have come and gone, but the stones have not moved. Whoever built that platform, whenever they built it, understood something about this planet that we are only now beginning to recover. Something about how the Earth moves, something about how to build structures that survive not decades, not centuries, but millennia. And the evidence is not buried in some lost archive. It is not hidden in a classified document. It is sitting in the Bekaa Valley, in plain sight, holding up the ruins of every civilization that came after it. The question is not whether the evidence is there. The question is whether we are ready to take it seriously.